Thank you. I'm really excited to be here, and let's see, here we go. I'm very grateful to Inedo for having InedoCon, for asking me to speak here. I really hope that you guys get something out of our story and where we've been and where we're going as an organization. I work for WebMD Health Services. I'm a software architect. At heart, I consider myself a developer. I love to get in, write code, solve problems, be an engineer. Now, when you think of WebMD, usually you think of the website where you go and it tells you have lupus or some other deadly disease. But that's not the part of WebMD that I work for. I work for the part of WebMD called WebMD Health Services. And our software, we try to make people more healthy. We have a private portal that we sell to employers that their employees can use to get healthier. We have coaching programs that people can enroll in to quit smoking, lose weight. We do manage rewards programs so that employers can say, we'll give you these benefits for doing these healthy activities. We have challenges where employers can do walking challenges or other kind of challenges. Our software helps people get and be healthy. And I started with WebMD way back about 13 years ago. I've been with them for a long, long, long time. And this is back in, I think .NET 2.0 had just come out, somewhere around there. And after your first day, getting to know everybody, introductions, pleasantries, orientations, team lunches, blah, 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 you finally get to your desk and you sit down, and it's time to get your machine configured to run the application. And these were our developer setup instructions. First you had to check out the code. And this is a rather large code base, so that took a few minutes. Then you had to either build the software, which took several minutes, or copy the latest binaries from somewhere. Then you had to install these certificates. You go find them and track them down and get them installed on your machine. And then you had to set up this environment variable. And then you had to add these settings to your machine config. And then you had to add this database connection stream to your machine config. And then you had to install this third-party software. And then you had to install this other third-party software. And then you had to, I don't remember anymore, you have to get administrator rights to read your machine keys for some weird reason. I still, to this day, don't understand. Then you had to install yet another piece of software. And then you had to go do this. And then you had, oh my gosh, and the steps. They just never ended. And of course, by the time you get to the end of the steps, you try to run the web application, you get a yellow screen of death. It's not working. There's some configuration that you are still missing. And so I had to go out and find the person that knew what the error message meant. And then they told me who knew what configuration my machine was missing. I had to go track them down to get that missing configuration applied to my machine. And because it was such a large code base, every few months you move to different parts, there would be some other configuration that you would discover you were missing. This was just extremely, extremely painful of a process to go through. So many steps. So let's talk a little bit about this code base and what made it so challenging. It's a monolithic application. It's one single code base. It has millions and millions of lines of code. It is a multi-gigabytes in size web application. The compiled binaries are about 500 megabytes in size. We have 150 plus .NET compiled projects that need to get compiled at build time. We have over 200 assemblies in our bin because of all the third-party dependencies that we had to bring in. A whole bunch of console apps that we use to run nightly processes or one-time processes or whatever kind of processes we needed that didn't involve the web application. A bunch of Windows services, and dozens of web services. This thing is ginormous, and yeah. And this was what our release process looked like. So you had developers checking in code to the repository, and we had 3 releases a year. Every 4 months we would release to live. And so we essentially had 3 branches. We had our mainline branches where active development went, and developers would check in code to mainline. We'd have a build that would compile, run some unit tests, and then deploy it out to a dev and test environment. We then had a branch for
the release that we were about to deploy live, like a month, month and a half, we would code freeze, create this branch so we have a stable place to make any future changes, and then we would build and compile into that release's dev and test environment. Now, for higher environments, for staging live, we did not have a place in source control for that. We actually had a file share where developers had to manually copy their files to this share to build and deploy to our staging higher environments. And the reasons for this are lost to the sands of time. I can't remember to this day why we did that. Some reason. But you can only imagine the chaos that this would ensue at release time, and that somebody may have forgotten to copy a file, or the more tragic problem was when somebody copied over somebody else's changes. Like you and another developer working on the same file, but made different changes, and you happen to copy over some changes that somebody else made. Really hard to find and track down. And also, every time we did a release, we had these were all static environments, so we had to actually go in and reconfigure these environments every release for this new release as we incremented release numbers and release dates. If you had any configuration changes for the servers, if you had new web services, new Windows services, or the configuration of anything else changed, you had to let operations know so they could go in and manually make those same configuration changes. And then somebody had to, at the time, developers were responsible for managing the dev environment. So developers would go in and make configuration changes to dev to make sure it was working, and then forget to tell operations. And so when it was time to release, things didn't work, and you had to track down what the problem was. It was awesome. Now, I keep mentioning release night. Release night was quite the affair. They brought in dinner, fortunately. They fed us. But you were usually there until 10, 11, 12, midnight, 1 a.m. Usually between 11 and 1 a.m. is when you finally got out. But that was just the beginning, because then you had a morning crew that had to come in. They brought in breakfast, but you had to be there about 6 a.m. to continue the release process from the night before. And we had a whole bunch of nightly batch processes and things like that somebody had to come in and check on and make sure they ran okay and there weren't any errors. And if there were errors that happened, as the East Coast was waking up and used our software, you were able to come in and figure that out. So this is where I kind of came in. After about 3 years, 2.5, 3 years of working at WebMD, an opportunity arose for me to take over build automation. There was very little automation around all this stuff. There was nobody dedicated to it. It was just whenever somebody had time or there was a real problem, somebody would dive in, fix it, and then dive back out and get back to writing software. And so I went to my manager and said, hey, I want to go do build automation full time. And he kind of looked at me funny and went back to his managers and came back and said, yes, you can go ahead and do build automation full time, but he said, I don't recommend it. I recommend that you get in, do what you want to do, whatever it is you want to do, you crazy build person, and then get out and go back and come back and be a developer. He didn't see it as a very good career move. And so it kind of begs the question, well, why would I want to go away from being a developer to being a build engineer? Well, first of all, this code base it was a house of cards. It was and is really challenging to make changes to the thing, because if you made a change, I'm not kidding here, you would make a change over in this part of the code base over here, and release night, you would discover that you affected something over here that had nothing to do with what change you made. It was really painful. And it's really expensive to change. That's the big thing is, we could go in and make changes. We could go in and make it better, but it's really expensive. It takes a lot of time, a lot of engineer hours, and that's just not a price that we're in the business to make money. And doing that doesn't really make the business money. And so there was just no money. There was just no time to do it. Anybody who's read, reason number 2, anybody who's read Programming Pearls by Larry Wall, he's talked about the 3 great virtues of a programmer: laziness, impatience, and hubris. Well, for me, there's really only one great virtue of somebody who wants to automate things, and that's an aggressive hostility toward boredom. I hate being bored. Manual setup instructions, I think I'd rather quit a job and go somewhere else. I have to be able to automate things. I will spend days automating tasks that only take a few minutes because I can't stand being bored that much. I could also see that the future of web development was JavaScript, and I don't like JavaScript. There's not much good in JavaScript world as far as I'm concerned. And so I wanted to go focus on something else besides having to write JavaScript every day. And lastly, I really like to help people. And as a build engineer, I could work really close with my customers, the developers, and I could write tools that they needed. Like they could come to my desk and say, hey, I need this. And within a day, a few hours, however long, I could then turn around and give them something they needed. And it was really satisfying to be able to help people and see that what I was doing was making a difference. It was really nice to work that close to my customers. Now I had a long-term vision for what I wanted our release process or our release pattern to look like. I wanted the left side is pretty easy. You have a repository, you check code in, you check code out, back and forth. I wanted to improve stuff on the right. And my philosophy is build quality in, automate the quality in, right? So that on your build server, you check out the code that people are committing, you build the code if you need to, but then you'll do a whole bunch of automated checks. You just automate the crap out of ensuring the quality of your software. And then when all your automated tests pass, package it up, stick it in a package repository somewhere, and then deploy that package out to your various environments. You don't rebuild it again like we were currently doing. You don't rebuild it for staging. You take the same package that you've built somewhere and tested in your dev environment, your test environment, and you deploy that out. Well, why do I like this pattern? Well, I think it builds quality in. I'm a big fan of automated testing. I write automated tests myself. I don't, for most of what I've been doing, we never had a dedicated QA, so I had to make sure my stuff worked, and it worked the first time. So I was responsible for ensuring that quality. I had to write a whole bunch of automated tests to build that quality in. The old pattern that we followed, because we built the software in different places and deployed it, we were actually deploying different software to staging that was tested in test, right? Because people were manually copying files to that file share to build it. And so you had to duplicate your entire testing effort. You couldn't test in one environment and know that same code that you're testing was going to get deployed to the next environment. It was different code, basically a different code base. So then you had to retest everything. You had to go through a whole new suite of regression testing in that environment. And that cost a lot of time and money. Also with our old process, you couldn't roll back. We could only push forward. If there were any problems, we had to fix those problems. There was no old code base, there was no old package, there was no old version that we could roll back to. We had to continually push forward and fix what was broken as fast as we possibly could. It also, when you automate the release process, the deployment process, it's way more reliable because you don't have manual steps that people can forget or do wrong or somehow do incorrectly. So for about the first year, it was just me doing this build automation. I was focused on, one thing I forgot to mention was packaging. When you package up the apps, you don't just package up, I didn't want to just package up the app code. I wanted to actually package up install scripts along with the app so that you could deploy the app with its install scripts, deploy it to a server, and install it. So that no matter what server you were deploying to, at the end of your deployment process, you had a functioning application. And I also wanted to get rid of that huge, ginormous, disgusting manual setup checklist. I wanted to be able to use the same installation scripts on developer machines that we were using in the dev environments so that we could not duplicate code, but we also maybe encourage developers to contribute when they had configuration changes. We could say, just go into our install scripts and make those configuration changes and then have them on release night magically show up in the correct environments. But it quickly became apparent that we needed a team focused on build automation. And so I kept asking, we need more people, we need more people. There was way too much technical debt around build automation. Now, why would you need a team dedicated to it? Up to this point, they'd done okay, with maybe just me for a little while. Why do you need a team? Well, there's a difference between designing, let's take cars, for example. There's a difference between designing a car and manufacturing the car. When you they work closely together, right? The manufacturing informs the design, and the design informs the manufacturing, but they're different skill sets, they're different responsibilities and that you need. And it's the same thing when you're building software. Designing and software is different than deploying it. It's different than building it, automating the quality in, deploying it. They're slightly different skill sets and slightly different focuses. And so I'm a big believer in having people that are dedicated and understand the manufacturing. And some developers like all aspects of building and building their software and deploying it, but most developers, they just want to build their software, and they don't really want to care too much about the deployment process other than did it work. And so when you have a team dedicated to it, lets developers focus on what they bring value on as in developing software. And fortunately, with about a year, we were able to get a team. We formed a team, we called it our Lifecycle Services team, because we kind of saw ourselves as the people responsible for the software development lifecycle. We hired a couple of engineers. Unfortunately, one of those engineers left after a few months, and we weren't able to fill that position. So for many, many years, it was me and another engineer doing all the build and install automation at our organization. And we got to a point where this was our new developer setup instructions. You clone the repo, and you ran install.ps1. And at the end, when that finished, after about 5 or 10 minutes, you had a running application on your machine. We were super proud of it. And it worked on our dev environment too. Every release now, instead of having to go in and manually reconfigure the dev environment for that release, we would just log into the machine and run the install script ourselves manually. Now, what about that release process? The organization wanted to go faster. They knew that releasing every 4 months was suboptimal. The longer you take to release your changes, the riskier it is to make that release and the more problems you're going to have. Because the longer you go, the more chances are that a change you made was made early in the process, and maybe the person that made it has quit, or maybe they've totally forgotten the change that they made. Maybe they forgot to copy that file out to the build server. Maybe they forgot to tell the DBAs about a DBA change. There's all sorts of problems that can go wrong the longer you go. And there's more integration problems. If you've made a change over here and somebody's made a change over there, the longer you go, the more chances that you're gonna interact with each other. And so they wanted to go from a 4-month release cycle down to once a month. And there is a slight problem with that, in that when you're dealing with a monolith, some features take way longer than a month to develop. Some features can take 6, 7, 8 months to develop. Well, how do you release monthly if you've got features that take 6 months to develop? And so we needed to be able to separate the deploy of our code from the release of our code. We wanted to be able to continuously deploy our code and release when we needed to. And there are a couple approaches we could have taken. One was using feature branches. And so what you do in your source control tool is you make a branch for your feature, and you hack away at this feature for several months, and then when you're done with it, you merge it back into the main line and you release it. Again, the longer this feature branch exists, it still incurs risk. It still incurs that risk because you're not integrating as much as you can with other teams. So you could be doing things that could really be impacting team, and then dropping your 6-month feature on other teams can cause chaos. For us as well, we had a very static environment, and so for these features, we would have needed to spin up dedicated builds so that we could automate, we could compile and run unit tests and do other automation against each feature branch. And then we would have needed dedicated databases and dedicated environments to deploy that code to, so that QA could then test it and verify that it was working as well. And we didn't have the capacity or the ability to spin up these feature branches. The other approach is to use what are called feature flags. And so actually you build this into your code, and you have this ability to say, hey, is this feature on or is this feature off? And if the feature is off, you continue to do things the way you normally have done them. And if the feature is on, you do them the cool, new, fancy way. And we were able to turn these on and off per environment, so that down in dev, the QA, if they're testing this new feature, they could turn it on and test to make sure that it's working, and then they could turn it off and test that it still works when it's turned off. And then we could deploy the code out to production. And this is the approach that we chose. And so developers, I'm not sure how long it took to build this into the application, probably about 6 months if I was to guess. So we had to update the code base to support this feature flag. We had to build a UI around it so we could enable them and disable them. And we're also able to build into the system scheduling of features. So we could say, we want this feature to automatically turn on this date, which was really useful for when we had client-facing features and things like that. We could turn certain features on certain dates. And then we had to update our build processes to support it. And this was about 6 or 7 years after I started as a build engineer. That's when we moved to these monthly releases, this monthly release cadence. And this really reduced the risks in our releases. And so this is what our new release process looked like. There's no more build, there's no more file copy, there's no more merging by copy, releasing by file copy. Everything came from source. We had a main line and a branch for each release. And for each branch, we built that branch and then deployed it out to dev and test. And then each release branch also had a dev and test environment that we had to build and deploy them out. And then we would deploy those built changes to staging and eventually out to live. Now we still had a release night. We still got fed once a month, got some dinner, but fortunately we were able to. Release night was cut down to about 3 or 4 hours. You were usually out of there by 8 or 9 o'clock at night. But sadly, there was no breakfast. There was no need to have a morning team anymore. So let's talk a little bit about our monolith architecture for a second. Let's kind of step back a few years. So this is a monolith architecture that doesn't do anything useful. This is a monolith architecture that does lots of very useful things. This is what a typical monolithic thing does, is everything depends on everything else. From the UI all the way down to the database layer. You have no idea if you own a component, what other components are calling you, what other components are bypassing you and going directly to your data in the database and doing funny things with. Lots of dependencies. Now you can kind of see why it was really expensive for us to make changes in our monolith because of all of these dependencies. Let's see. And so the first approach we tried to take to make this better, we tried to tighten up these lines and isolate things inside our monolith. We try to make compile time decoupling internally. And this was a several year effort pattern that we tried to adopt and use. And essentially we were trying to get to this. We wanted to have components of our monolith have a public front door that anything that wanted information from that component would have to go through the front door. That's the only way you could get information. You couldn't go through a backdoor. You couldn't go directly to their database. You had to go through the front door to get what you wanted. And that way, as a developer, you were free to change whatever you wanted in the private implementation. You could change your database. You could change the internals. As long as your front door was there and it didn't change, you could do whatever you wanted internally, which gives you a lot of flexibility to make big changes and big improvements to your code base. Now, unfortunately, when you're dealing with a monolith, you still have all these backdoors. You still have all these backdoors that are there. And so if you really want to get to only a front door, again, you still have to take the time to do it. You still have to take time to close all those back doors and make everybody go through your front doors. New code was great because if you had new features that you wanted to add, you would build the front doors and with no back doors, and then people had to go through that front door to get access to it. But you still had all the old code that we weren't updating. And plus, our database is structured in such a way that we couldn't lock down the database. We couldn't say that only this component had access to this data. So if anybody wanted to, they could just go bypass all your backdoors and just go right to the data in your database. You were definitely not free to make changes, no matter even with this change. And so we tried and tried and tried, and it just didn't work out. And eventually we gave up. And so around the time that we went to our monthly releases is around the time where we started to actually move to a more service-oriented approach, where instead of trying to decouple inside the monolith, all new code would be deployed as independent services. And we were able to do this with our user interface. We were able to deploy independent user interfaces, and we were also able to deploy independent services. And so we were actually able to achieve this with all new code. We still had the monolith, and we kind of had hooks into the monolith that you could, if you needed to get stuff from that or the monolith needed to call out, we still had those. But new code had a new pattern and a new release process. And this was all automated. This all followed the pattern, the vision that I had for our monolith eventually, where everything got built and automated, tested and packaged and deployed out, automatically got installed at deploy time. Unfortunately, this was all done by the development teams without collaborating with our Lifecycle Services team. We weren't included in all this new stuff. You kind of heard whisperings over a few months of what was going on, but didn't really think too much about it. But it took about a year for me to kind of clue on what was going on. They'd done some awesome work, but now we were in different places. So we had 2 different build servers that we were using. We had 3 different build tools that we were using at build time to build our code. We had 2 different deployment tools that we were using. We had 3 different release patterns and 2 different source control tools. And so I saw this as a problem. In my view, I thought the more tools and patterns and processes that you have, the more complexity you have as an organization. And I believe in simplifying things. And I wanted one thing. For each of these bullet points, I wanted one thing that we were all using together, or a plan to get there. And so I got our management and managers together and said, hey, we have a lot of expertise in build tools. We've been doing this a long time. We really want to own these build tools and work with you on coming together on one pattern, one platform, one tool base. And they said no. At the time, they wanted development to handle it. They wanted develop to basically not have any dependencies and to manage all their own tools and processes. So I was disappointed, but went off and continued to work on our monolith. And a few months later, our C-level executives brought in some consultants. And I don't know why they brought them. I don't know what the reasons were. But they brought them in, and they talked to a bunch of people in the room, in the organization, and when the dust settled, we had new management. And this new management, they kind of understood the design versus manufacturing paradigm that I shared earlier, where when you have a team that you should have a team dedicated to that build automation, so that developers can focus on where they bring value. They bring value in developing software, not necessarily delivering it. And if you have a team that's dedicated to delivering it, you can deliver a little bit faster, a little bit easier, a little bit better when you have a team focused on that. And the developer's time isn't split between different responsibilities. And so we were actually able to hire 2 more engineers. We brought our team count up to 4 at this point. And we also took ownership of all our build and deployment processes. And so our first effort was to let's consolidate, let's get down to one thing. And it took about a year to 2 years to get everything over, including our monolith. But eventually we were able to consolidate on one source control tool, one build server, one release pattern, and one deployment tool. About a few months after the reorganization, development came to us and said, we're using this development tool that's given to us by WebMD.com, our corporate overlords, but we don't like it. We don't want to use it. Go find us a better deployment tool. And so we went out and we evaluated tools, and I guess you guys will never guess what we chose. We chose BuildMaster, and about a year after the reorganization is when we rolled out BuildMaster and started actually using it to deploy our UI apps and our services out to our live environment. So we hooked up our deploys for new things. So when somebody created something new, it automatically go into BuildMaster, and then we slowly migrated existing stuff into BuildMaster. And it took about a year to get everything migrated out and over into BuildMaster and off of corporate tools. And so this is what our deployment process looks like. There's an arrow missing, I apologize. The left-hand side hasn't changed, but now we have automated process so that whenever developers commit changes, it fires off a build, it runs, compiles code as needed, depending on what the application is, It packages it up, sticks it in a package repository, and then triggers a deploy in BuildMaster. BuildMaster automatically deploys to dev and test. And then you can see these little keys. Part of our process requires approvals to go to staging and live, and requires certain people, only certain people can deploy to those environments. And so our QA engineers have those permissions. So if you want to deploy to those environments, QA has to actually go into BuildMaster and manually click buttons to do those deploys. And the last thing, let's see. And we're using this same release process, this release pattern, across all our applications that get deployed live. And we even got the monolith a little bit into BuildMaster. We haven't got it all the way, but it's partially there in BuildMaster. And we actually moved to weekly releases. So we went from a monthly release cadence to a weekly release cadence. Moving to the source control tool, that was the big change. Moving from our old source control tool to our new one enabled us to move much more faster and move to a weekly release cadence. And so, yeah, after the last application we moved in was the Monolith, and we moved to weekly releases, and there are no more release nights. We release code in the afternoon every Wednesday, and we're usually out of there at the end of normal business hours. Occasionally, maybe something might go wrong, but we're typically out of there at normal times, which unfortunately leaves us with a bunch of hungry developers. So that's where we're at. That's where we're at today. What's next? What do I want to? And these are my opinions. This isn't necessarily where we're actually spending much effort, but this is where I want to see us go in the future. The first is I want to see us move to an immutable infrastructure. Right now, we deploy to static servers. It's always the same servers, always the same servers. And I want to see us move to an immutable infrastructure where when you deploy to some new thing, whether that's a VM or a container or whatever it is. You deploy it to some new thing, install your software, make sure that it's running, and then change things so that it starts taking traffic, and then you pull the old ones out. This forces you to capture all the configuration of your software. It also reduces the impact on operations because they don't have to go spin up new servers all the time. You get really good at spinning up new containers or new VMs or whatever you're deploying to dynamically. We also need to do a better job of automating our database changes. We because of the nature of our databases, we have really unique deployment requirements. And so developers will script database changes. And then our DBAs will get those changes into a format where they have a tool that then automatically deploys them. But that middle process of converting changes into that artifact is a manual process done by our DBAs. And we want to automate that completely so that when developers commit a change, the database changes go with them and they get deployed at deploy time as well to take out that manual step. We also want to be able to integrate better smoke tests when we deploy. Right now, we just do some very basic, we just make sure the application is essentially running whenever we deploy it. Each of our applications have what we call health checks in them. And we basically deploy the application, install it, and then make sure the health checks are responding and saying, yes, I'm running, I'm okay. We want to be able to do some more smoke tests. We want QA to be able to write higher level tests to check actual functionality, to make sure that things got deployed and are working correctly. This one we're actually actively working on. Our QA architect is taking this, and he's actually building in the hooks into our BuildMaster pipeline so that QAs can start doing this and running these kinds of tests. And I also want to be able to have some build isolation. We have a bunch of our platform we've released as open source software on GitHub, and we use a tool called AppFair. I'm not sure if people are familiar with it to build the software. But what it gives you, every time you run a build, it gives you a dedicated VM. And at first I didn't really understand what the value for that was. But when I started writing PowerShell modules to integrate with ProGit and BuildMaster, the light kind of came on. I said, oh, in my build script, I can actually install ProGit. I can actually install BuildMaster on this VM, and I can run tests against it for my PowerShell module. I didn't have to have a BuildMaster instance somewhere that I could hit or install one locally on my machine and only run the tests locally. I could do whatever I wanted on my build machine to make sure that my software was running. And so I really want to be able to give developers in QA an isolated build environment. So they can also, if they integrate with 3 or 4 other services, they can download those services during their build and run tests on their service that hits those services to make sure things are working. Those kinds of things. So that's where we are. That's where we were. That's where we are. That's where I hope I can get us to in the future. But it's a journey. There is no finish line. There's no end. There's no we're done. We don't need a build team anymore. We're done. Right? Everything's perfect. There's always going to be technical debt that you've got to pay off. There's always going to be new features. There's new platforms. There's new tools. There's new technologies, and they've all got to be integrated and automated. So the journey continues. So I thank you for your time. Are there any questions?
So I think Mike had asked me what would have been the way at Ohio Savings Bank to fix their old platform, and I think actually you just explained it. Yeah, I think you showed the journey. But I mean, a question that I wrote it down. That dev setup instructions that you showed earlier, which was just the run a PowerShell script. Now this was for the Monolith.
This was for the Monolith, yep. And when the development team started doing service-oriented stuff, the service-oriented, decoupled, we call them decoupled services. They did the same thing. They made sure that there were install scripts for each service. They actually had they had a build tool that you actually imported into your project, and it did the building and included that install script for you. Yeah. So when the developers did that, they also included install scripts. And our UI apps don't need install scripts. So.
What was one of the bigger challenges that you had, with adapting into the automation culture? Like not the technological piece, but like organizational or like something that had, because you can always install new tools, new platforms, but what was the piece that sort of surprised you as the hardest part outside of technology?
The biggest thing that surprised me was that many people didn't even know that you could automate things.
Huh.
I remember one time we were in a conversation with our operations team, and we had let them know that we automated the install of the Monolith. And he was just like, "How did you do that?" And he literally didn't understand how we were able to automate that. And at the time, there was no PowerShell. It was all weird, crazy technology that I wouldn't want to share with anybody today. But we were able to do it. So it's the mindset of instead of having to clicky, mousey, pointy to do things, you could actually. It was just having the automation mind that you could actually do it. And I think just demonstrate that you could. Is the first step. That's what I did. I just demonstrated that it worked, and yeah. All right. Thank you very much.